Date 2024 rate process. As shown in the figure, the two rods of different metals of equal length, L by 2 and diameter D, the constant thermal conductivities. Conductor K1 and K2, where K1 is greater than K2, are connected perfectly. Zero interface thermal resistance. So the left and right hand cells are connected and maintained at temperature T1. Assuming the rods are insulated. So here we got to know that K1 is greater than K2. When K1 is greater than K2, the thermal conductivity, it means the temperature is falling quickly at the interface. So the temperature is distributed uh, in a steady state heat condition is given by Q is equal to minus K into dt by dx. So Q is constant. So K1 dt by dx is equal to K2 dt by dx. So dt by dx of 1 by dt by dx of 2 is equal to K2 by K1, which is if K1 by K1 by K2 is greater than 1, this can be taken as 0.5. So dt by dx is 0.5, then d2 by dt is 1. So the slope will be decreasing slower, and then it is decreasing faster for this one. Then assume some values and check it for corrections. As shown in the figure, the right right end of a slender rod cylinder, long cylinder, solid cylinder metal rod of thermoconductivity K and length L, diameter, which where diameter is less than length, is in contact with an infinite liquid heat sink. This is the liquid heat sink. At a steady state, the temperature at the right hand of the rod and heat sink T2 and T0 respectively. The convection heat transfer coefficient between the liquid heat sink and the right end of the rod is H. Then what will be the temperature of the left end of the rod at a steady state? So if you'll assume steady state condition, Q conductivity is equal to minus Ka dt by dx. So, uh, this is also equal to Q convection Ha T2 minus T0, and this is equal to T1 minus T2. So, minus Ka T1 minus T2 by L is equal to Ha T2 minus T0. So, you wanted to find the conductivity is given. So you can write this as A gets cancelled. So you want to find T1. So T1 minus T2 is equal to HL minus HL by K into T2 minus T0. So T1 is equal to T2 minus HL by K into T2 minus T0. So this is equal to T1 equal to T2. Conduction is flowing in this direction, T1 minus T2. And the convection is also flowing in this direction, T2 minus T1. So it will be T2 minus T1 equal to minus HA by we have made a mistake here. So it will be T2 plus T2 minus T0 into HL by K. Okay. So match the dimensions number listed in column 1 with their application to transport phenomena. Reynolds number. Reynolds number gives uh, the distinguishes between the transition from laminar flow to turbulent flow. So it is 4. And Schmidt number is used to tell the momentum and mass transfer. So momentum and mass transfer is 1. So Prandtl number gives the relation between momentum and heat transfer. The Prandtl number is for heat transfer, and Biot number is for convection to convective to conductive heat transfer. 3, 4, 1, 2, 3. Reynolds number is nothing but the inertial force by viscous force. It is rho v L by mu. And the transition from laminar to turbulent in a fluid dynamics is given by Schmidt number is nothing but the ratio of momentum diffusivity to mass diffusivity. So momentum diffusivity by mass diffusivity, which is equal to mu by rho dm. So here, if you see, it is similar to mass transfer processes involving different fluids or mass transfer regimes. So Prandtl number is nothing but the ratio of momentum diffusivity to thermal diffusivity alpha. So it is similar to heat transfer involving different fluids. So Biot number is the convective internal resistance related to external resistance in transient heat transfer. It is HL by K. Conductive resistance to the convective resistance. A non-porous spherical Fe2O3 particle of initial radius of initial radius 5 into 10 power minus 2 meters is topographically chemically reduced by H2, where the reactant product interface is sharp and spherical. The reaction rate is proportional to interfacial area. dr by dt, reaction rate is proportional to interfacial area, and the radius of the unreacted Fe2O3 particle after 600 seconds will be. So here it is given as the particle initial radius r is equal to 5 into 10 power minus 2 meters is topographically reduced by H2, where the reactant is sharp and spherical movement. The reaction rate is proportional to interfacial area. The radius of the unreacted surface particle is, if you'll see, uh, so it is given as dr by dt is k. So dw by dt is proportional to area by 4 pi r square. So you can write volume into density. So it is density into the value is 4 pi by 3 r cube, 4 pi by 3 d r cube by dt. So it is rho into 4 pi r square into dr by dt is proportional to 4 pi r square into some k. So 4 pi r square, 4 pi r square gets cancelled. This is k. So dr by dt is some minus k value. Okay. Now we got to know like r is changing from initial radius r naught to r. So it is r is equal to r naught minus kt. If you differentiate this, integrate this. So you know r is equal to 5 into 10 power minus 2. R naught is equal to 5 into 10 power minus 2. K is equal to 5 into 10 power minus 5. Okay. So it's given, K value is given. So you'll get to know like uh, R is equal to 5 into 10 power minus 2 minus 5 into 10 power minus 5 into 600 seconds. This is equal to 5 into 10 power minus 2 minus 0.03, which is 0.02 meters. It is 2 into 10 power minus 2 meters. A long metallic cylindrical rod of radius R and length L, if electrical resistivity rho E is kept in a vacuum and is carried an electric current of I. The only way it loses heat to ambient is radiation. If the ambient temperature is T naught, this steady state temperature of the rod is dash. So Stephen Boltzmann constant is given as 5.66 into 10 power minus 8. R and other values are given. Like Q heat generated is equal to I square R. And this is equal to radiation loss, which is sigma epsilon A T power 4 minus T naught power 4. And resistance is nothing but rho L by A. Okay, so it is resistivity into length by pi r square. So you'll get I square into rho L by pi r square is equal to sigma into epsilon into 2 pi r L, because this is the surface area on which it is happening. So it is T power 4 minus T naught power 4. So you have I square as I square as um, 0.3 square into resistivity is 10 power minus 8 into length is 1 meter by pi into R as 0.1 into 10 power minus 3 whole square, which is equal to sigma is 5.67 into 10 power minus 8 into epsilon is given as the neglect the heat losses. So epsilon is given as 1 into 2 into 3.14 into R is given as 10 power minus 4 into length is given as 1 and T power 4 minus T naught is given as uh, the ambient temperature is 300 power 4. So you get, if you'll calculate, you'll get T power 4 is equal to value of implies T is equal to power 1 by 4. So it is 307 Kelvin. It is 307. As it is a very small thin wire, so the ambient temperature and the heat loss radiation final temperature reaches only 3 knots. Thank you.